Hello, and welcome to the Olympus webinar on the automatic product sampler, which uses XRF technology for operational efficiency in coal power plants and also the mining industry. My name is Christopher Lane from Olympus, and I'll be your host for today's webinar. And I'm joined by Hendrix Bauer from EEE, one of our co-collaborators on this project, and also Vincent Lee from Olympus Singapore. So before we start, just a bit of housekeeping. So please note that this webinar will be recorded. So if your colleagues are unable to watch it online, it will be available for demand to watch offline. If you're having any issues with the audio, select the audio button and you can choose the most appropriate audio selection for you. Please note that you won't be able to ask any questions through the voice, through your microphone. So if you do have any questions, please do type them in to the Q&A box, and we intend to answer as many questions as possible. So we've left about 20 minutes at the end of the webinar to try and answer as many questions as possible. If we're not able, then we will contact you offline to follow up. So I will introduce my presenters. So first of all, we have Hendrix from Energy Efficiency Engineering. So Hendrix is the CEO of EEE, and he holds a degree in engineering management. He's got over 10 years experience in the thermal power plant industry. And in 2016, he set up the company EEE to provide technologies and solutions into the power industry. And in 2019, working with Olympus, he developed the APS technology, which we'll discuss today during this webinar. We're also joined by Vincent Lee, who's a regional product and application manager for XRF and XRD technology at Olympus Singapore. Vincent has got a degree in a Bachelor of Chemistry. He's got many years, 5 years of experience working with XRF, XRD and other scientific solution equipment. And he will support Olympus on ANI and other analytical technology. So before we start going, we would just like to we'll just go quickly through the contents of today. So in a second, we'll have a poll, but before we do, we'll just go through the contents. So first of all, Vincent will talk about APS, what is it, just to give you a flavor of what we're going to be discussing. Then he'll break down with Hendrix the key components into the sample collection, preparation, and then analysis. Hendrix and Vincent will then take you through the benefits of the APS for the coal industry and also the mining industry. We'll go through the software features, and then we will look at some customer return on investment for both coal and mining. We'll finish with conclusions, and then, as I said, we'll try and leave plenty of time for Q&A. So please do start putting your questions into the questions box. So before we get going, we'll start with a quick poll. So if we could launch the first poll, please. The first poll is going to ask you, what is your primary interest today? What is your main industry that you're interested in? Is it mining? Is it coal power plants? Or is it NDT equipment sales? So as we wait for these the questions to come in, we'll give you a few more seconds. And we've got about 30 people that already answered, more and more now. So there seems to be a fairly even split actually between mining, coal power and also NDT sales. So it looks like we have a good audience today that's split between those three applications. Okay, so without further ado, I will now pass you over to my colleague Vincent, who will take you through APS at a glance. Over to you, Vincent.
Thank you very much, Chris. So, hi, I'm Vincent. Good afternoon, everyone. So, I will be talking about just a summary of what is this automatic product sampler that I'll be talking about today. So basically, this will be an autonomous analysis whereby the entire process, starting from sample collection all the way to sample analysis, it will be an automated process. So no human will be involved, and you will be able to get real-time data coming into your system. And you guys will be able to make real-time decisions on what to do with the process, etc. Okay, so the purpose is really to make or to improve the product efficiency. Okay, So moving on, I'll pass this to Hendrik, who will be sharing with us some of the key components of the APS. Okay, starting with sample collection. Hendrik, to you.
Hi, yeah, thank you, Vincent. Yes, today we want to talk about the key components of the APS. APS stands for Automatic Product Sampler. This is the name we have given this this machine. Actually, it's also an automated laboratory process. First, we do a sample collection, which comes straight off of the belt. The belt doesn't need to slow down, and we will collect exactly 15 kilos. This is a system called a mechanical cross belt sampler. Yeah. Second picture is a animated picture of our sample preparation or the automated laboratory. There's size, sample size segregation. There is crushing. There is a moisture measurement. There's XRF analysis, and then a selection or a discard of the actual sample. The third picture that you see is the picture of the front of our actual section of the APS that does the XRF analysis. And we'll get into that a little bit later on. Vincent? Excellent. So the video, this is a video, is a slow motion of the mechanical cross belt sampler, right? So this boom hammer whips across the belt and takes a 15 kilo sample of the product. These belts can be running up to 3 meters a second, and carrying up to 500 more than 500 kilos per minute. Yeah. So yes, exactly. So what happens after it's taken off the belt, it goes down a chute, and in the section below the belt, we have placed the sample preparation. Yeah. So within this sample preparation process, we'll have a quick view at the animation. So the product is coming down the chute. This could be ore or this could be coal. They go through a separating screen, through the first crusher, another separating screen. Then there's a butterfly valve that separates exactly 500 grams. Then it goes through a pulverizer, and then there's a moisture measurement done, and a puck is formed. A puck is formed that is then automatically carried under the XRF. We'll have another video seeing the details of that final process. Yes, thank you, Vincent. The details of the APS, as I mentioned before, we are taking a 15 kilo sample, which is then being crushed by the first crusher. This is according to the ASTM laboratory standards. From that, we're going from a 50 millimeter, maximum 50 millimeter product size to 4.5 millimeters. That's coming through the crusher number 1, which is a regular jaw crusher. And then we're going into the second process, which we're taking the product from 4.5 millimeters to 200 microns with a hammer crusher. And of course, for coal and ore, this is customized according to the needs of the end user. Finally, we control the entire preparation process, and in between sample taking, we have an automated self-cleaning system to avoid cross-contamination. Now the sample is ready for the XRF. Vincent, please carry on.
Thank you, Hendrik. So before we continue to talk about more on the sample analysis using XRF, we'd like to have a second poll. So this poll will be checking with you guys on what is the current laboratory waiting time when they are sending off a sample. So is your laboratory in-house, or do you have or do you send it to a third-party laboratory? So this will actually give us more information about the lead time that you guys are getting, and how long does it take for you guys to get a result. Okay. Okay, I think a fair bit of you are getting the results between 2 to 5 days, but I do see some of you guys are selecting 2 weeks or 3 weeks or more as well, which is pretty concerning to a certain level. Okay.
Yes, exactly. This is the predicament which we have found that pushed us to come with a solution to provide real-time laboratory results, and this is possible with the Olympus XRF technology. And within our collaboration, we have been able to automate this process, and we are very excited about this.
Yeah. Okay, so now let me move on to the next part for sample analysis. Okay, so over here, I'll briefly touch on the technology itself that we're using here, X-ray fluorescent, which I do believe many of you are familiarized with, but just a quick one on the theory. So what happened is the X-ray tube will send out an X-ray, which will kick out the innermost electron over here, as you can see. The electron closest to it will replace the one that's being kicked out. So when this process of replacing of electrons occur or happens, a unique fluorescent energy is given. And every single element in the periodic table have its own unique energy range. And that is how we are able to identify what are the elements that is present in your sample. Okay, so over here, I will just want to have a quick question as well. Whether are you guys an existing XRF user, or are you guys using other destructive methods such as ICP OES or ICP MS? Okay. Oh, it's good. More than 50% of you guys are an existing XRF user. Okay. Okay, I'll show. Let me move on. Okay, so next is a simple video of overview of our new product, which is the Vanta IX, which is for integration. Okay, so with the Vanta IX, you can connect it either through a PLC or through API as well, which I'll discuss a little bit later. So over here, this video will show you an scenario for steel bar analysis. So what happened is the Vanta IX is being used to verify whether the grade of the steel bars is actually according to the specification that is required. Okay, so as you can see, you will be able to, there's an online system as well that will say that is it a 316 or not. So if it's a 316, they will just move on and the steel bar will go into the approved area or the pass inventory. So as you can see, it's just a matter of 3 seconds and will be able to identify the grade. Okay, so if it passes, it moves on to the pass inventory. Then example for now, as you can see, if there is a grade that fails the 316 requirement through the PLC, this bar will be removed from the entire process. Okay, and with the Vanta IX itself, is made more robust for the industry as well. Okay, so over here, this is the sample analysis that we have already installed, and this is what Hendrik was talking about earlier. Okay, so over here you can see that the part has been pressed. Okay, then you will see the part moving to the analyzer soon.
Yeah, maybe restart the video. Yeah.
Yeah. Sorry.
Okay. Rolling. Yeah.
So there are some mechanical sensors, etc., that's been built in line with this. So Hendrik, do you want to share about some of the mechanical features of this system?
Yes, exactly. Yeah, we've seen that the need to compact the product into a solid mass, which we call a puck. This is a 500-gram sample according to ASTM. It's very important for the XRF to be within a 1.5 millimeter range above the sample for accurate reading. So we have placed sensors on the XRF for it to lower exactly to that distance above the sample. What you see right here is actually a handheld XRF. This is a generation before the XRF XI that Vincent just showed us. We're very excited about utilizing this. We are now utilizing this in the next generation of the APS. But it comes down to the same features as what you know in your handheld XRF are actually in the XRF XI. Isn't that correct, Vincent?
Yeah, I mean, that's right. So with this, you can see that with the Vanta IX, in terms of reliability and analytical capabilities, exactly the same as the handheld XRF. So it can measure up to 30 elements in one measurement. And for certain key elements, we are able to measure down to 1 ppm if required. So as what Hendrik mentioned earlier, for XRF analysis itself, sample prep is one of the crucial part of this, because at the end of the day, XRF is a surface measurement. So the sample prep, we need to make sure the sample is homogeneous before we put it in front of the XRF in order to get a representative data. And with the latest Vanta IX itself, we are able to measure light elements as well, such as magnesium, aluminum, silicon, phosphorus, and sulfur, which could be key penalty elements that you're looking at in your process. Okay.
I think that it's quite unique for the XRF to be able to measure down to the ppm level. We've compared it to other technologies, and this is quite a unique feature of the XRF. So
yes.
the amount of element that needs to be present in the sample for the XRF to detect it only needs to be at the parts per million. Isn't that correct?
Yep, that's right. That's right. So we can measure from parts per million, or we can even measure up the percentage with this Vanta IX system itself, which currently we don't see any automated system having this capability, especially with the light elements analysis, such as magnesium, which is one of the lightest element that XRF can measure. Okay, so with this Vanta IX, we actually managed to increase its analytical capability, so that we are able to provide more data or more accurate readings to our customers.
Yeah, and that's very exciting especially for our colleagues in the coal-fired power plants. Magnesium, aluminum oxide being key elements in the ash composition, and key elements in calculating slagging and the fouling index. So we're very excited about this. Yeah.
And with the Vanta IX, it's very easy to integrate. As you can see, this is what you see is what you get. So all you need is one of this, and this is just an analyzer, and you are able to you don't need any external control box. And with this analyzer itself, you are able to use either a PLC, or you can use a Vanta Connect API control. So there are many ways, and we are very flexible in terms of connection. And of course, with the APS system itself, everything is integrated. So we are able to customize the solutions that you require according to your requirements. Okay, and Hendrik will share with you a little bit more on the software with the APS as well later on. Okay. Yeah. And finally, the Vanta IX is rugged, so it has been vibration tested. It's IP54 rated, and it does have industrial locking connectors. So with this itself, it makes it more robust and made for industrial usage. Okay, and you are able to do 24/7 operation with this new product Vanta IX as well. Okay.
What's the Vanta IX's tolerance to dust and moisture? We can take a good amount of dust and a good amount of moisture in its environment. Isn't that correct, Vincent?
Yeah, because it's IP54 rated, so it's dust tight and water resistant. So even if there are jet sprays, or if it gets splashed with water, etc., yep, no issue with that. And I do believe that with the APS itself, we do include some cleaning or blowing, etc. This is something that we can do as well to prevent any contamination with the equipment as well. And basically, the maintenance is very straightforward with this XRF equipment. All you need to do is to change this window when it gets dirty. And changing the window probably takes you less than 1 minute to do it. So with this toolless window changement as well, it makes maintenance relatively easy. And you guys don't need a very complicated maintenance with the equipment itself. Okay.
Excellent, excellent. Yeah, we try to build a very low maintenance system. We're utilizing the best products in the market for our PLCs. For example, we're using Siemens. The entire body of the APS is out of stainless steel 306. So we are going for the highest grade materials. We are providing a standard splash-proof housing. If a customer requires different types of housings for different types of environments, this is all possible. We are ready to deliver whatever you need for your environment in your situation.
Yep. So now we have one more question. So what is the amount of product does one sample that you send to the lab currently represent? So meaning to say, how often are you sending? Yeah, how often are you sending a sample to lab? Is it every 10,000 ton, whether every 25,000 ton, 50,000 ton, or 100,000 ton? Okay.
Yeah, so either a coal barge arrives at your power plant, you know, that could represent 10,000 tons. There could be a barge representing 25,000 tons. You take one sample, you send it to the laboratory. Or when you're a mine operator, you send one sample to the laboratory. What type of stockpile does that represent? Maybe it's 50,000 tons, which you have to then wait a week or 2 weeks to get a laboratory report back for you then to make the decisions as to what to do with your product.
Yep. Yeah, so by having this system, APS itself, it does improve the productivity and efficiency a lot more, whereby you are getting XRF data on the spot.
So what we
and
do,
you can
we're able to take a sample every 15 minutes. So with about 500 kilos per minute, that represents 7,500 kilos, right? So 7.5 tons are represented by each sample taking of the APS. So the accuracy or the amount of information that you are going to get over your stockpile is exponentially higher than just one sample representing 10,000 tons, for example.
Okay, thank you, everyone. Okay, so next, moving on. So Hendrik will be sharing with us some of the benefits of the APS. So he will start to talk about the profitability in data and being able to do real-time analysis. Okay, Hendrik, please.
Excellent. Yeah, let's take it off. So first, I want to talk a little bit about the coal-fired power plants. Yeah, as many of you know, I spent quite some time working with the coal-fired power plants, and one of the issues that we see with subbituminous coal is that it's quite porous, and the conditions of the coal change over the period that is on the stockpile. The coal will come off the barge, sit in the coal yard for 2 to 3 weeks, and then it is brought into the power plant for to be burnt. Now, the laboratory report that a coal-fired power plant operator has in hand is 3 weeks old, and therefore, technically speaking, we are looking at a completely different product by the time it is put into the power plant to be combusted. It has different moisture content. This affects the total sulfur. Because it's quite porous, the oxidation of the elements which are the ash composition, these have changed. Therefore, our slagging and our fouling index has completely changed. And this is something that's very important to make the correct decisions as to how to set your operational settings for your combustion, you know, your primary air, your secondary air, your mill speed. And all these decisions are actually now made based on information that's a couple of weeks old, representing 10,000s of tons. Now we can get this information real time for every 7,500 tons that is entering your silos. So it's also very important that what we can see here, what we discussed earlier, light elements are analyzed at a almost laboratory accuracy. We have been able to tune the calculation of the oxides down to a 10% repeatability of test, which we're very excited about. Let's have a look at what this can mean for your power plant efficiency and your and avoiding possible forced shutdowns due to fouling. Shall we go to the next slide real quick? Right. So improving the revenue of your power plant, this is what every power plant operator is looking for. And of course, what we want to provide is the correct tool to make those decisions to achieve that goal. We are going by a very simple calculation of boiler efficiency. Rule of thumb, a drop of 15 degrees Celsius of the economizer exit temperature equates to 1% boiler efficiency improvement. Yeah? And especially for our friends that are operating larger power plants within the range of 5, 6, 700 megawatts up to 1,000 megawatts. This is very significant when we can improve the efficiency by 1%. And technically speaking, the 1% is not the limit. We could easily push this up to 2 to 3% in boiler efficiency. Let's have a look at a example case study. Shall we? Yes, perfect. So let's take this 700 megawatt power plant. We have a heat rate before. We were making decisions with the APS of 11,764 and the heat rate after 11,627. Now that's an improvement of 137. Yeah, now quick calculation, 137, 680 megawatt net production times 24 times 13.41 power purchasing value divided by 1,000. Yeah, so very simple efficiency calculation equals to 29,982 per day, which with a approximately 330-day operation equates to $9.9 million per year for 1% efficiency improvement. Now, this is not including the avoidance of forced shutdowns due to fouling. And this does not include the possibility of smart soot blowing, not wasting the steam on areas that are not fouled. Because we now know what the ash composition is, we can also predict in which part of the boiler this ash is going to land. Of course, what we want is we want fly ash, high quality fly ash. We don't want slagging. We don't want the ash to melt. And all these things are possible with the APS by controlling the ash fusion temperature and the furnace exit temperature. This way we keep the ash in a solid state and easily to be removed by your soot blowers. And by avoiding these buildups, of course, we are avoiding these unplanned shutdowns, which we hate. These unplanned shutdowns can be caused by fouling, can be caused by tube leakage due to heat flux or erosion, or can be caused just by a large amount of slag coming down in your furnace and tripping your submerged scrape conveyor. Perfect. Let's have a look. The other thing is that with a complete combustion, we can control the quality of fly ash. Now, in many countries, for take Thailand as an example, fly ash has a market value of above $20 for the type F, ASTM type F fly ash that is a byproduct of coal combustion. Now, with this value that it has towards the concrete and cement industry, this side product, especially if you can control the quality of it, has a exponential value to earn for your power plant in the sales of this product. A lot of people are struggling with keeping this quality consistent, and therefore this is a secondary issue for them. But here is another opportunity that we have that we can improve. Right, perfect. Vincent, I'll hand over to you for the mining part, 3.3.
Sure. So now Hendrik has done a terrific job talking about how the APS can be used in the coal industry to improve efficiency and to prevent unplanned shutdowns. So in terms of the mining industry, it's slightly different. So with the mining industry itself, it can be used from the raw material sorting as well. So we can achieve a homogeneous sampling through the mechanical sampling that you see earlier. So by that, we are able to use a crusher to crush it down to 200 microns, homogenize it, make it into a puck, so that this sample will be representative of the whole stockpile that you intend to measure. Okay, and by having this, you will have unbiased samples, and from this, you will avoid having inaccurate chemical result or inaccurate chemistry. Okay, so, and all of us know that if we are measuring a rock, if you're measuring different spots on rock, you can have different XRF reading. So by having this mechanical crusher and sampling itself, we can avoid unhomogeneous samples. Okay, and we do have zero impact on belt speed. So if required, the Vanta X will be able, we can configure the Vanta X to move along with the belt as well, so to prevent any stopping. Or preferably, if you are able to stop the sample at one point of the belt for the XRF to do a measurement for a minute or so, that would be great as well. But like as I mentioned as well, if we are able to measure the samples when it is moving on the belt as well. So all these are possible with the Vanta X configuration. Okay, and also quality control on the ore grade, so you won't get any penalty fees. You can determine you can separate the ore grading through this system as well, and by that we can optimize profitability. So we can determine what is the grade of ore going into the processing or the treatment itself to concentrate the ore. So we'll be easily able to separate the low concentration ore and the high concentration ore, or when we want to blend it to a mid-range concentration, all this can be set up by using this APS system. Okay, so effectively, this is the same process as what you guys are doing in the laboratory by getting samples into the lab, crushing it in the lab, prepping it, and running through XRF or destructive method. But with the APS, you can do all of this on site, and data get pumped through into your software or your system immediately without having to go through a tedious process of putting in an Excel spreadsheet, etc. Okay, so by this, you can sort of optimize your profitability and improve your revenue. Okay, and in terms of treatment process, as I mentioned earlier, with the real-time data given to you, you will have an idea how is the state of your ore through every single stage of processing. And by that, you are able to know whether additional process is required in order to improve the quality of your ore, and also to help recover the concentration or the grade that you intend. And lastly, by knowing the raw material composition beforehand, you can then decide how much acid or other leaching compound to use, compared to you not knowing what is the quality of your raw material and having a standard calculation. By knowing the actual composition of the sample, how much clays the sample has, etc., you can then increase or reduce the amount of acid that you want to use before the treatment process. So all these calculations and all these logarithms can all be included into the APS software as well. So we are able to customize this according to what requirement you need in treating your ore. Okay.
Excellent.
Yep. And now Henry will share with you some of the software features that the APS have. Hendrik.
Thank you, Vincent. Yes, exactly what Vincent was saying earlier. I mean, we can integrate our software system with your DCS system and customize it to the point that it meets your needs. This we're very excited about. We've built a very flexible platform that is a cloud-based platform, which we will have a statistical record of your operation, which is of course completely only disclosed to you and your team. And with this, you can also get features of data analysis over a period of time that then can help you make better decisions. This can be to the point that we can activate features that can give you advice towards how to set your operational process of digestion and leaching. And for the power plants, we can give you advice towards what are the best combustion settings for this type of coal. Now, as time goes on, the more accurate the information is going to be, that is going to be advised to your operators. And we are very excited about this part, and this is something that will become an exponential benefit to the operator, as this information is going to be very easy to analyze, pull into graphs, or other features can be semi-automated, that you have a pop-up window giving you certain advice that can then be conveyed directly to your DCS system. Really up to you the way you would like to see it. Now, our first interface of the display of the samples, I would like to show you a couple of videos as to what it looks like for a coal-fired power plant. Now, for the mining industry, these features are quite similar, and we can customize these exactly towards your process. Now, when we take a sample, this is the home screen. This is the list of samples that have been taken, and we know which silo it's going to, which is silo E at this point. We know where the sample is, as we know the belt speed, we know the tripper speed, and we know the filling and feeding speed of the silo. Now, when we click on the information button, then we get the information about the silo that we have. Then we can see the samples are in this silo. For this video, there was one sample in the silo. This could be up to 5 samples that we're tracking through one silo. Then when we click on the sample information, we see when the sample has been taken, when it arrived on the conveyor, and then we see the compounds and ratios. On the left-hand side is the chemistry readings of the XRF, and on the right-hand side, we have the tags from the DCS system. Now, this is your combustion settings, including your settings for your process, or your readings of your process. Now, we go back to the page. And right, the next feature for power plants, which is very interesting, is the upcoming candidates feature, which is the average of 5 to 6 silos that you're operating and are feeding into your boiler. Now, this is actually the blend information. This is the information about your blend. You can then track and see which set of samples are at the same level of the silo, and that is automatically taken as the blend. So you could be looking at 5 or 6 different blends in one silo at one time. So you have information 3 to 5 hours in advance before it enters the furnace. So this is ample time for us to adjust mill speeds, primary air, velocity and volume, secondary air, velocity and volume, all in consideration with the furnace exit temperature and the current ash fusion temperature. Now, certain elements might fuse at 1100 degrees. Certain elements might fuse at 12 or 1300 degrees. So this really gives us the opportunity to maximize our thermal conductivity and thermal efficiency, and therefore improve our boiler efficiency by keeping this ash in a solid state, easily to be removed by the soot blowers, and therefore not building up on your tubes, keeping your economizer exit temperature at optimal levels. Perfect, thank you, Vincent. And the next part that I wanted to talk about is the AI feature that we have built for the power industry and also for the mining industry. It's the same platform. It's the same cloud-based system. What we do is we collect the data and we do a statistical analysis of the data. So what we're taking into account is the chemistry, which we have taken from the XRF, the humidity, separate probe. We are taking into account the operational settings, your feeding speed, your mill speed, your airflows, and with all this data that's being collected is then cross-referenced, and we're going to then look, what's your heat rate, your gross calorific value, yeah, what type of ash we have, what's the ash composition, what's the ash fusion temperatures, and with this data, we then come back and say, okay, we previously had this type of coal, this type of ash composition at this calorific value. Last time, the optimal settings were A, B, C, D, E. We will have then a pop-up come to the operator and say, hey, we advise you to make these changes. And then linked to that, there will be certain graphs that you can then reference to and make a very educated decision about your combustion settings. Now, this would work very similarly in the mining industry, as we will take the similar information, in this case, your feed of your acids or your other leaching products, customized to the amount of ore, amount of elements, say copper, that is present in your ore, so that no waste is, there's no wastage. Yeah, you're not wasting acid, or you're not feeding too little acid in and then wasting the actual product that is then going out, to the waste pile. So this is really what we're trying to do here, is really optimize your process to give you the maximum efficiency. Perfect. Customer return of investment. So the previous scenario, which I discussed with you about the coal-fired power plants, was based on efficiency. Now, what if you are forced to shut down? So with a large power plant, we have at least 24 hours to 48 hours of cool down before you can safely enter the boiler to do a repair or to do manual cleaning or whatever the situation is. Now, then you might be working on that for 1 or 2 days, and you have to start up for another 12 hours. So usually 3 to 4 days minimum are wasted. Now, with these large power plants, we all know that that's about $1 million a day that we're losing, right? So when we can avoid one of these shutdowns by making sure that the ash stays in a solid form and does not melt and become slag. In the first picture, I would like you to have a close look where the arrow is. These are pendant superheater tubes that are hanging inside of the furnace. Now, this buildup that you see here is approximately the size of a car. When that comes down, it has the possibility of rupturing a tube at the slope below, or to trip your submerged scrape conveyor. And when this happens, a lot of manual work needs to occur and the plant has to be shut down. So we want to help you avoid these type of buildups. Now, quick calculation. What we see is that if you have a net loss of 1.4 million per day, and this is speaking gross, yeah, and these shutdowns are taken, a week or 2 weeks, technically speaking, for the cost of one APS, your return upon investment is only 1.5 days of saved shutdowns. And this is not even considering the efficiency improvements that you are going to receive by knowing exactly what you're putting into your boiler. So looking at this, anywhere between 10 and 20 million US dollars are easily achieved by the implementation of the APS technology. Excellent, Vincent. Let's have a look at the next one. All right, I'll hand that one over to you.
Yeah, thanks, Hendrik. So with Andrew has covered pretty detailedly in terms of the coal fire power plant itself. So in terms of mining itself, as Hendrik mentioned, we are able to customize the APS software into a smart system, whereby in the future, it will be able, after collecting tons of data, it will be able to give you advices even on the calculation of how much acid to use versus the ratio of recovery as well. So with this, the system itself, we are able to go down to a very precise amount of acid or leaching component to use. So an example on this is that with the APS, we are able to improve copper yield by 20 to 30%. So if we talk about the standard yield, we are probably looking at around 0.6 to 1% per ton from the copper ores that we mine, okay, which is around 6 to 10 kg per ton. So if you're looking at the improvement of 20%, so it will be around average of 1.2 kilo per ton. So if you look at a day, if we are processing around 270 tons of ore per day, it will be an improvement of 1,620. And with this, the yield would be probably around 1,620 tons per day for copper. Then if we look at a 20% improvement, we will be improving the copper processing rate by around 324 tons per day. So if we multiply by a year, it could end up saving more than $1.2 million a year by using this system. So we are able to increase the efficiency or the productivity of the copper recovery. And also we were able to save on the chemicals that we use for the processing. And
that's
of course,
right. Yep. I think this is,
and of course we are able to save up time as well. So with this equipment, with this APS system itself, we are getting real-time data with respect with the comparing to the conventional ways whereby you guys are sending to the lab. It takes at least, the fastest, if there's no samples lining up, it will still take you at least 1 day or 2 days to get the actual data for a few samples. Whereby with this, the APS is constantly storing the data. We are getting a very big data pool. And by using the data pool, we are able to customize or improve the efficiency or the quality of the copper that you guys are actually concentrating. Okay. Oh, sorry, Hendrik, you were saying?
But in this calculation, we have not included possible savings of the chemicals. And we have not included the possible repercussions of some mines are sending their ore to be processed, and the ore has to be within a certain quality range, right? So in this case, there could be certain fines attached to that. Also, by not knowing exactly what the amount of copper in this case is within the ore. So you send it down to the processing plants. Processing plants are not getting exactly what they want. A fine gets sent to the mines. So this is a very conservative number, right? Isn't that, Vincent?
Yeah, that's right. So like what Henry has mentioned, this is purely based on the improvement of copper yield that we can have with the APS. There's nothing that's been considered in terms of the saving on the consumables or saving manpower itself, resources itself. So all that hasn't been calculated in this. So this is purely more on improving the productivity. the amount of copper that you are able to process daily. So this is more on the calculation is more based on that. Okay, so with this, I will launch the final poll that we have. So lastly, we want to find out how for mining customers, how much mining materials are you processing daily? So are you doing more than 500,000 tons per day, or are you doing between 100 to 500, or are you doing less than 100? Or unfortunately, if you're not a mining customer, you can choose not applicable as well.
Yeah, it's very exciting to see so many of you participate in the polls. Thank you so much. I mean, this is really going to give us some information to really support you, you know, with further questions of about the APS. Yeah, but this is very helpful. Thank you very much for participating in these polls.
Yeah, it's very encouraging to see all the replies through the polls, etc. And also, as of now, I mean, we are coming close to the end of the presentation. So if you guys do have any questions, you can start keying them in the Q&A box. Okay, so after this poll, Hendrik will go through the conclusions. Then thereafter, we'll start answering some questions from the floor. Okay, so in the meantime, if you have any questions, feel free to enter them in the Q&A box. And during the Q&A session, we will start answering some of them. Okay, so yep. Okay, thank you very much, everyone, for the poll. So now moving to the last section. So Hendrik, please.
Oh, yeah. So in conclusion, now we got one picture or animated picture of the entire process. As you see, on top we have the mechanical crossbelt sampler, and then it goes down the chute, and this is where our automated laboratory is. So yeah, technically it takes two floors of let's say a transfer tower to install this. The footprint of the APS is approximately 2 meters, 2.5 meters by 2.5 meters, and the mechanical crossbelt sampler bolts just onto the frame of your conveyor belt. And this all can be, for example, for coal-fired power plants, we can do this in between bunkering sessions. The crossbelt sampler, the mechanical crossbelt sampler, it only takes about 2 hours to install once it's lifted on. So these are exciting things. We don't have to wait for a shutdown. This can be implemented at any time of the year where we have a 4 to 5 hour window in between bunkering sessions, and we can install the APS for you. Now for the mining sector, I mean, if you have a belt that can be put out of operation for 3 to 4 hours, we can install the crossbelt sampler. The rest below, we can install at any time during operation. So I would like to confirm this to you. We don't have to wait for a shutdown to install this amazing product for you. Let's have a quick look at the main features. So let's summarize. We have advanced software capabilities, a direct real-time input to the plant control system, and an AI advisory system. So really with the digital transformation in mind that many companies are talking about, I think this is something that can be very beneficial to you. Second thing is we're using the highest quality materials to manufacture the system. This includes all the electrical materials, the housing, and all the moving parts. It is designed according to the ISO and ASTM standards, and we are speaking of laboratory standards in this case. Very easy to implement. That's what I was saying earlier. We can do this seamlessly online during operation. Just give us a small window of 4 to 5 hours to lift the crossbelt sampler on. And then the whole system is profit oriented. We are here to make money for you. This is a very short-term ROI, and this can be delivered to you in also within a short lead time, and we can help you to improve your process immediately. It's fully automated. It doesn't need calibration. And Vincent can confirm that. I think what we calibrate the XRF once a year. What was?
Yep. I mean, there are reference materials that we do use more like a verification. In terms of calibration, the equipment does not require to be calibrated every year. So in the process of analyzing, we are able to include some QC samples into the into the system as well, so that we can make sure that the XRF is giving you a accurate reading. And when there's something wrong with it, probably there will be an error message, and we will be able to resolve the issue from there.
And on all our mechanical equipment, we have sensors. We know exactly how many hours they have operated. We have an automated troubleshooting system, which is available to the operator to know exactly if he's looking at a mechanical error or electrical error. So, and we can log in externally at any time to help you troubleshoot. And the most important part, of course, about this system is that you are getting your real-time laboratory results displayed within 5 minutes after the sample has been taken. Sample sequence is every 15 minutes and represents 7,500 kilograms. 7.5 tons each sample. And all this data is available for you statistically. We are keeping it over the whole runtime of the APS, cloud-based, accessible to your team at any time.
Okay, thank you very much, Hendrik, for concluding the session. So I'm sorry, guys. There's only a little bit more time.
We've got about 5 minutes for questions.
Yep.
So what I think we'll do is I've tried to categorize them into the different stages, so collection, preparation, analysis. So let's try and get through as many as possible. Some people have been asking about specific costs and ROI. I think the best thing to do for those questions is either contact your Olympus rep, or we'll contact you offline, because the whole APS can be customized to your end needs. So it's best to talk specific about your application. Okay, so let's go through as many questions as possible. So from the collection side of things, and I guess Hendrik, at what speed does the belt move? Do we stop the belts when we're taking a collection?
The belt moves at about 3 meters per second, and this is really up to the condition of the client. Yeah. So when we make a technical proposal, we will have a questionnaire. We will know exactly what type of belt you have, and the mechanical cross belt sampler will be manufactured according to that specification. So whatever type of situation you have, we will manufacture it accordingly. No reduction in belt speed. That's the conclusion.
Okay, so I think that's the important thing. So no need to slow the belt. Okay, so if we move on to preparation, so there's a couple of questions about moisture.
Yes.
So firstly, there's why is the moisture measurement taken, and also then how is the measurement moisture taken? So how and the why.
Yeah. So moisture measurement is taken because that's something that our end users are requiring. We are taking it in between the first and the second crusher, which is by the weighing station. It is taken by a moisture probe. So what we are actually measuring here is a surface moisture, and then an inherent moisture, and a total moisture is calculated.
And of course, with moisture as well, it does affect the XRF reading as well. So at the end of the day, we need to know roughly what is the moisture level, or whether is this moisture content consistent throughout all the samples as well. So with higher moisture, it might cause certain concentration to become more diluted and become lower. So by having a good grasp on the moisture content, it will able to help us do some back calculation in terms of the XRF reading as well.
Perfect.
So thank you very much. We move on to analysis. There's some questions on the difference between the handheld and the IX, but I think Vincent, you explained that the IX, if you've experienced the handheld, you're getting exactly the same performance, excellent sensitivity on light elements. We had some specific questions about, and this is where we're showing the video, the air gap It says, why is the air gap needed between the sample and XRF? So I think this is really about your controlling the air gap rather than needing one. So perhaps Hendricks, do you want to answer that?
Yes, yes. So what we want is to bring the XRF within a range of 1 to 1.5 millimeter off the sample. That's exactly actually the XRF landing on the sample. That's the range between the lens and the sample. And to do that, to make it land exactly on top of that, of course, you need to use a sensor.
Yeah, I mean,
And,
in terms of performance wise, when you're doing this measurement, especially for light elements, we will be using the highest model that we have, which is the M series. So the M series with the large area detector, we are able to increase the analytical performance of the equipment. And by saying that a small little gap will not create a big impact in the reading. And of course, I think this is dependent on your design as well, and depends on the elements that you're looking at as well. So ultimately, if there is a requirement, we can always customize the equipment with a laser detector. Am I right, Christopher or Hendrik?
Yes,
so that we can get the exact contact as well.
Yes.
So it depends ultimately on the customer's requirement. So this system can actually be improved based on your requirement.
So yeah, so to rush you, we've got, I think, probably time for two quick questions, about two more minutes. So there's a question, talking about reliability. So if we're operating 24/7, we're continuously collecting data, we're getting data in real time, we're collecting every 15 minutes. So therefore, how long do we expect the detector to last, and how often might we need to change the detector tube? So Vincent, do you want to address that one?
Sure. So I mean, in terms of the equipment itself, the X-ray tube is something similar to a light bulb. So as long it depends on your usage as well. So but normally when customers come in for automated system itself, we do recommend to get you guys to get at least a standby, so that in any time when is down, you can simply change the Vanta IX, the standby unit, with the working the spoiled one. So and the changing of the Vanta IX is seamless. You just need to disconnect the equipment and then plug the standby unit in, and you can resume operation. So the Vanta IX is customized such a way that even replacing it is seamless. You do not need to have a shutdown of a few days in order for us to come down to do the changing, etc. It can all be done by your own engineer or your own team.
Yeah, and I think that the follow-up question from the same attendee was, is it wise to have a spare Vanta on standard? Then yes, it probably is wise, and it could be, plug and play, one swap from the other in case. And then finally, I think a very pragmatic question about how do you keep the crushed puck in a cylinder shape? How do you prevent it falling apart?
We do that.
Hendricks,
we do that by hydraulic pressure. I believe it's 5,000 psi. And well, I mean, this is just very simple mechanics, and just use enough. We figured out we need to use enough pressure to keep it together. Yeah.
And of course, I mean, in terms of mining samples, if there are different types of mining samples, we can include some other mechanical way to make it fix like a part instead. So it depends ultimately on what is the sample that you guys are looking at. So for coal, like what Hendrik mentioned, is simple. We just need to have a fixed amount of pressure, and pretty much it will stay as a part. But for mining as well, some of the samples, if there are requirements to add in some fixed stabilizer, etc., we can look into all this and add it into our system as well. So as we always mention to you guys, our system is highly customizable according to your requirements.
And don't forget that if you require another NDT system to be part of this process, we can definitely have a look at including that. I've heard some of our power plant customers asking about grindability, hard growth grindability index, and there's possibilities to include one of these systems in the APS if that's something that you require. Yeah. Absolutely.
Yes, I think it's we've come to the end of our allotted hour, so I think that's a good point to end. So yes, this is the start of the conversation. So this is just meant to whet your appetite. As I said, please do contact your Olympus rep and we would be more than happy to have follow-up sessions one-on-one and talk about your specific applications for the APS. So I'd just like to thank Vincent and Hendrix, and thank you very much for attending today's webinar. Thank you.
Thank you. Thank you, everybody.
Thank you, everyone. Have a good day. See you guys.